Generative AI is changing how we write software at a crazy fast pace. But here's the thing. Beneath this amazing revolution in speed, a massive and silent security crisis is brewing. Today, we're going to break down the very real threat of a new practice called vibe coding. This quote from AI pioneer Andrej Karpathy, man, it just hits the nail on the head. It perfectly captures the seductive idea behind this whole movement. You just let go, you trust the AI completely, and you move at an unbelievable speed. But what actually happens when we forget the code exists?
I mean, the promise here is just incredible. We're talking about tiny teams deploying huge, enterprise-scale applications at a speed that was totally unimaginable just a couple of years ago. It feels like all the hard parts of coding are just melting away.
So, what does this mean for developers? Well, your role fundamentally changes. You're no longer the one painstakingly writing every single line of logic. Instead, you become a manager of intent. You just describe what you want, and the AI handles all the nitty-gritty details.
Okay, so that's the dream, right? But now we have to pivot from that incredible promise to the hidden crisis. All this speed, all this new creative freedom, it comes at a staggering cost that we're only now really starting to understand.
So what is that hidden cost? When we trade rigorous, careful engineering for pure velocity, what are we actually giving up? The answer is stark, and it's a little scary. It's security.
Check out this number. This comes from serious studies by places like Georgetown's Center for Security and Emerging Technology. It shows that nearly half, 48%, of the raw code pumped out by popular AI tools contains at least one severe security vulnerability. Think about that. That's a coin flip chance of introducing a major flaw every single time you generate a piece of code.
And look, we're not seeing some exotic, brand new kind of attack here. The AI is consistently making the classic devastating mistakes. We're talking stuff like SQL injection, which lets an attacker just dump your entire database, or hard-coded credentials, where the AI will literally write your secret API keys and passwords right into the source code. These are well-known vulnerabilities, cataloged in what's called the Common Weakness Enumeration, or CWE, and now they're being mass-produced by AI.
Now, this isn't just a theoretical problem. Let's move on to a real-world disaster to see how this all comes together into a full-blown catastrophe. The case of the startup Lovable is really the canary in the coal mine for this entire movement. The core failure in the Lovable case came down to one thing: row-level security. You can think of it as the digital walls inside a shared database that keep one customer's data completely separate from another's. It's the invisible scaffolding of privacy, and it's absolutely critical.
And this is the number that should keep every tech leader awake at night. A security audit discovered that 170 applications built on Lovable's platform were missing this critical security layer. The AI was brilliant at building the visible parts of the app, the stuff you could see, but it completely forgot to install the locks. And the consequences were total. We're talking private user data, emails, phone numbers, payment details, all exposed to the entire internet. Secret API keys were leaked. And in the worst cases, attackers didn't just have read access, they could actually write to the databases, corrupting data or injecting their own malware. A total disaster. So, as if just plain-old buggy code wasn't enough, an entirely new and really insidious attack vector has emerged that actually weaponizes the very nature of how these AI models think.
It's called package hallucination. You ask the AI to suggest a software library for a specific task, and it confidently just makes one up. It invents a name that sounds perfectly plausible, like a statistical ghost, but the package itself doesn't actually exist.
And this is the attack that exploits it, known as Slopsquatting. Here's how it works. First, attackers find these phantom packages the AI keeps inventing. Then, they go and register those names in public code repositories and upload malware. So when a developer who is just trusting their AI assistant installs this ghost package, they are literally inviting the attack right through the front door.
Okay, so we've seen the scale of the problem, and it's pretty scary. But there is a clear, disciplined solution. It just requires a fundamental shift in our thinking, away from surrendering to the vibes and back towards structured engineering and control. This visual really shows the two paths forward. On the left, you've got vibe coding. It's a chaotic black box. It offers high speed, but you have very low control and massive risk. On the right is the solution, Agentic Engineering, which brings back high control and security by putting a human architect back in the loop. So what is Agentic Engineering?
It's a system where you treat AI not as some magical oracle, but more like a junior member of your team. You give it clear architectural blueprints, and you give it security rules it has to follow. It operates within your guardrails, rather than just guessing.
The difference in philosophy is just stark. Vibe coding is about giving in to the vibes. Agentic engineering is all about trust but verify. It's the difference between taking on a huge unknown risk and actually managing it. And ultimately, it's the difference between building up a mountain of technical debt and building secure, lasting systems.
So if you're a CTO or a tech lead watching this, you're probably asking, okay, what do I do right now? Well, here is a clear, actionable plan you can use to start building your defense against these new AI-driven threats.
First off, ban naked vibe coding, period. Mandate that no AI-generated code gets into production unless it has passed through a structured, verified pipeline. Second, audit your dependencies immediately. Hunt for those ghost packages, and use a private registry to block these squatting attacks. And third, make your infrastructure self-defending by enforcing policy as code. Use tools like Open Policy Agent or OPA, so it can automatically reject insecure configurations.
Which really brings us to our final, crucial question. The metric that truly matters in this new era isn't lines of code per day, it's vulnerabilities per release. So you have to ask yourself, is your team's innovation built on the illusion of speed, or is it built on a truly secure foundation?